Military forces have always needed space to train. It's crucial for preserving combat readiness, developing skills and capabilities, and to keep one step ahead of potential adversaries. It's particularly important now as NATO faces a more assertive Russia, growing instability in the Middle East and North Africa, and brutal attacks by ISIL and other terrorist groups on member states. The majority of training of NATO troops is carried out on military ranges. These large areas of land, sometimes thousands of acres in size, are necessary for soldiers to practice with a full range of weapons.
Our soldiers need to train, okay? The weapons that most nations are using now are getting more and more sophisticated. You need more and more time with those weapons, actually firing them, using them in simulated combat operations, using them with joint forces. You've got vehicles moving, you have air support, you have all sorts of things going on. You have to be accommodated to that type of scenario. And if you don't have these ranges, especially the larger ranges, you're at a deficit as far as training is concerned. You're going into combat without the necessary training to ensure you're going to stay alive.
These areas of land need to be maintained in a sustainable manner. One issue threatening their lifeline is contamination. Military units conduct live fire training with a wide variety of munitions that contain constituents that may have adverse impacts on the environment and human health. The military range in Massachusetts in the United States is 22,000 acres in size. Below the ground lies the primary drinking water supply for Cape Cod, an area with 200,000 inhabitants. The soil here is very porous, so material can easily migrate down into the water table. In the 1980s, the groundwater was found to be contaminated with toxicants from a decaying weapons disposal pit and jet fuel from a nearby Air Force base. The site was closed down.
It's gotten into the groundwater. A lot of people in the United States have drilled wells that go down in the ground, so it's sort of like a personal water supply. And when those wells get contaminated, people just don't have an option, because if the aquifer is contaminated, if the groundwater is contaminated, you have to buy water essentially.
To control risks and support range sustainability, it's important to recognise the types of residues that are released from different types of munitions during training. Some are more harmful than others. In order to quantify potential contamination, NATO has gathered some of the best scientists in this field and designed a cooperative demonstration of technology to show NATO and partner nations how best to characterise military training ranges for potentially contaminating munitions constituents to ensure the sustainability of these ranges.
You see that more and more nations struggle with that issue as environmental regulations, environmental rules, they continue to grow in various NATO nations and partner nations, which means all nations are facing the same problem. We have already achieved a lot of results. We have achieved a lot of good procedures, developed good tools, and now there's the right point in time to share that knowledge that we have developed within the NATO Science and Technology Organization framework.
At the Defence Academy of the United Kingdom, more than 30 representatives from 16 NATO nations and partner nations undertook a course in military range characterization to give them the skills needed to assess a range for potential contamination. The process starts with the sampling of soil and water.
We sample to find out the total amount or mass of metals or energetic residues that are on the base, to make sure that it's safe. We're not going to know what the concentration of contaminants are unless we actually collect a sample and take it to the laboratory for analysis. We can't tell out here in the field concentration levels and the part per million level, so we have to take a sample to send it to the analytical laboratory. Then once we know how much is out here, we can make a decision. Does this amount of contamination pose a risk to the soldiers' training or to people living around the area or to animals that may be migrating or grazing in the area? With water sampling, you have to be careful because the water is not the same everywhere. It could be different, like in a pond from the top to the bottom of a pond, or a stream from the left to the right side of a stream. especially if you have some kind of source or runoff on one side, you sample on the other side, you may miss it. So for any type of stream or pond, you want to be sure you collect increments or sample from everywhere within it to be sure that you represent it.
One of the pioneers of multi-increment sampling is the scientist Marianne Walsh. In the 1980s, she was asked to investigate why waterfowl were dying on a military training site in Alaska.
We sampled the site. At the time, we did not find any explosives, but we found one sample that gave off a vapor cloud. That was an indication of white phosphorus. White phosphorus is used by the Army as a smoke-producing munition. You know, it makes the big white cloud. It's been known for a long, long time that it's toxic by ingestion. And it only takes white phosphorus the size of a grain of sand that's enough to kill a duck.
Another expert in range characterization is Sonia Tibuto. She was one of the first to test military ranges in Canada for contamination.
So we had to convince the military people, and we built a burn tray, and now they're burning the excess propellants back at the magazine stores in a good burn tray, and all of this contaminated stuff go to dangerous good. It doesn't go to the groundwater anymore. So we want to keep our range open. We don't want to lose any range. In Western Canada, we have a range which spans over 2 provinces, the Air Force Range in Cold Lake. So it's really important to keep these assets healthy in order for our military to be in a readiness state forever. So what these people are doing, and behind me, they're collecting multi-increment sample in a 50 by 50 grids. We call that a decision unit. We decide what could be contaminated here. You need to take at least 100 subsample in a very specific way.
The multi-increment sampling method gives a more accurate determination of the mass of contamination in a given area. Once all the samples are taken, they're bagged up and sent to the laboratory for analysis.
So we've got the sample, it's all dried, and the next step is sieving. And we use the 2 millimeter sieve. Anything smaller than 2 millimeters will go through. The grass, we sometimes keep. The organic matter, we sometimes keep, depending on what we're looking at for a receptor. Moss, we always keep, because moss is very good at retaining material residues on the surface. You run this through the sieve. We don't force it through. And the material you see here would be the material that we go with for the next step when we do the grinding, okay? Generally, you know from the area where you're taking the sample what you're going to see. If it's a firing point where they're firing anything from a pistol to a 155 millimeter howitzer to some of even the big rockets that we've tested, the 8-inch rockets that we use in the US, those areas have certain propellants that they use. So it's a propellant that we're looking for. The components of propellants could be nitroglycerin, dinitrotoluene, all sorts of different things. Ammonium perchlorate in the rocket motors, things like that. Those are the type of compounds we would look at a firing point. Now, in an impact area, something different. Those are explosives. Things like TNT, everybody's heard of TNT. There's RDX, there's HMX, and there's newer compounds that we're now looking at.
The sieved and dried soil is then placed in a grinder to shrink the size of the sample particles. Energetics particles will be reduced in size and spread throughout the matrix of the soil sample. A 10-gram subsample of the ground soil is then taken using multi-increment sampling, just as the original sample was taken. This small subsample represents an area containing thousands of tons of soil. The next step is to extract the explosives in the soil into a solvent, in this case, acetonitrile.
A sandy soil with very, very high concentrations of explosives, the extraction time may be quite short. If it's a clay soil with very, very low concentrations of explosives, extraction time is long. The overnight extraction is a good compromise for the majority of soils that we've dealt with.
The 10-gram subsample is then mixed with water and filtered before injected into a chromatography instrument to measure the concentration of explosives in the soil extract. This whole process was new to most of the course participants.
I'm working in a joint range where you can find the Air Force for air-to-ground firing and as well the Army for ground-to-ground firing. And I command the air-to-ground part, and we are cleaning the range, doing a lot of stuff, but we never measure the soil pollution by the way we described this week. So we will have to work on it, I think.
At this moment, we have the protocol for testing the soils and waters, but it's not a systematic approach like the methods we have seen here, and we wanted to improve, to upgrade our capabilities in that field.
By teaming up all together, all of the country learns a lot from each other, and we don't repeat the mistakes, and we know what to look for if we go to an anti-tank range. Now, someone from Serbia may go back to his range, and he will know, he will be looking, for example, for HMX in the impact area, and he will be looking for propellant residue, not in front of the firing position, behind, because those shoulder rockets, they fire. Of course, you have a little propellant emitted there, but they have an open mouth behind. And by luck, we installed a decision unit behind just to see, because it was so heavily contaminated because you have a backblast.
The NATO Connected Forces initiative requires NATO members to effectively function as an integrated force. A key component of the CFI is an increase in size and tempo of joint military training on ranges in Europe. To meet this goal, ranges must be monitored to assure their continued availability. The long-term aim is to create a NATO standard, requiring all members to carry out tests on their ranges.
This particular activity, range remediation, could literally save billions of dollars to any one of our nation's militaries and keep operational ranges in action for a much greater part of the time. I hope that it will allow us to not waste money on cleaning up ranges so that NATO nations can modernize as they need to. Ultimately, what we're trying to do is not waste money, field better equipment, and train the young soldiers, sailors, airmen, and Marines in our forces better. The land space we have in the world is the land space we have. Every time we lose a range, we lose the ability to train some of our young forces.